Good morning, students. Today we are going to read the magnetic effect of a current in the subject of physics O levels, and this is lecture number 1. So concentrate yourself. Here we are going to read. The first thing that we are going to read is the magnetic field due to currents in straight wires. Electromagnetism is the study of the magnetic effect of an electric current. So this is the definition of the electromagnetism. It is the study of the magnetic effect of an electric current. If an electric current is passed through a wire, a weak magnetic field is produced around the wire. That may be checked by using the magnetic needle. So whenever the current passes through a wire, a weak magnetic field is produced around the wire. A plotting compass can be used to trace the circular magnetic field lines with the compass needle showing the direction. The field has 3 features, so concentrate yourself. This is a short question which frequently come in the paper. The field has 3 features. Number 1, the magnetic field lines are circular, like this one. The field is strongest close to wire. So as you go close to the wire, the field will be more stronger, and as you go far from the wire, the field will become weaker. Increasing the current, increasing the strength of the field. So this is another thing. The more the current, the more stronger will be the field, and less the current, less stronger will be the field. Current essentials. In a circuit, the current is a flow of the electrons, tiny particles which come from the atoms. The current arrows shows on circuit figure above run from positive to negative. So you can see this is the positive. The electrons run from the positive to negative. This is the conventional current direction. Electrons being negatively charged flow the other way. So the current's direction is on the other way, that is from negative to positive. But as far as the conventional current is concerned, the current arrow shows the circuit figure above run from positive to negative. To demonstrate the magnetic field, magnetic effect of an electric current, the apparatus used in this investigation is shown in the figure below. One side of the large rectangular shaped coil consisting of 6 to 10 turns of the thick insulated copper wire passes through the center of the horizontal perspex sheet, which is supported on the 4 pillars. The terminal of the coil are situated in the center of the side opposite to the hole and connected via a rheostat and ammeter to a direct current supply. Thus the current in the wire may be adjusted. So here you can see this will be the setup for the investigation. Place the coil so that its plane is in the magnetic meridian. So the coil will be placed in such a way that it will be in the magnetic meridian, that is pointing south north. Hold a compass needle over the horizontal top side of the coil and check that it points to the north. So look now, we are checking through the compass needle and the needles is pointing towards the north. Then switch on the current and current will be switched on. Then the compass needle is deflected. As you increases the magnitude of the current, the size of the deflection increases. So as the current is increased, the deflection will be more, and as the current will be less, the deflection will be less. When you place the needle below the wire, the deflection is in the opposite direction. Next, reverse the direction of the current. You will find that the reverse the direction of the deflection. So if we reverse the direction of the current, the direction of the deflection will also get reversed. Figure below summarizes what happens. So here you can see when the needle is placed above the coil, this is the direction, but it is when it is placed below the coil, the direction will be reversed. Like here, if you can see, if we change or reverse the direction of the current, the direction will be reversed if placed above the coil, and if we place below the coil, the compass needle's deflection will be will also be reversed. Now arrange a sheet of the paper on the perspective table so that the vertical side of the coil passes through the hole in the center of the paper, like this one. Use plotting compass to determine the line of the force around the vertical wires. These lines form a series of the concentric circles. So look now, concentric circles will be formed with the wire as their center. Figure C. The direction of the lines of the force is indicated in the diagram by the arrows. So arrows show the direction. Reversing the current, reverse the direction of the field. Here again, the Earth's field has an effect, but if a large current is used, the effect is not so obvious. So the thing is, if we reverse the direction of the current, the direction of the lines of the force will also be reversed. With using a plotting compass, there are two rules to help us relate the direction of the current to the direction of the magnetic field. So the thing is, if we want to check what is the direction of the current and what is the direction of the magnetic field, two rules are helpful. Number one, Maxwell's screw rule, and the second is right hand rule. So here we are going to read first the Maxwell's screw rule. If the right-handed screw is turned so that its forward movement is in the same direction of the flow of the current, then the direction of the rotation indicates the direction of the magnetic field. So look now, if a right-handed screw is tightened in the direction of the current, so look now, forward movement same as the direction of the current, then the direction of the rotation will be in the same direction of the magnetic field direction. So this is Maxwell screw rule. Next thing that we are going to read is the right hand grip rule. The direction of the magnetic field produced by a current is given by the right hand grip rule. Imagine gripping the wire with your right hand so that your thumb points in the conventional current direction. Your fingers then points in the same direction as the field lines. So here, if we grip the wire in such a way that our thumb points in the direction of the conventional current, then the direction of the fingers will be in the direction of the magnetic field. And reverse is also applied. If we grip the wire in such a way that our fingers are in the direction of the field, then the thumb will points in the direction of the conventional current. So this is a right hand grip rule. The direction of the magnetic field depends on the direction of the flow of the current. So definitely they are depending on each other. The direction of the magnetic field depends on the direction of the flow of the current, or the direction of the flow of the current depends on the direction of the magnetic field. So these are depending on each other. If the flow of the current is reversed, then the direction of the magnetic field will also be reversed. So here you can see when current flows into the paper away from you. So if current flows into the paper, magnetic field is clockwise direction. Okay, and when current is reversed, it means a flow out of the paper towards you. So if the current is flowing towards you, coming out of the paper, magnetic field is anti-clockwise. So this is very, very important point to be noted. When the current passes into the paper, the magnetic field will be in the clockwise direction, and when the current is reversed, it means flows out of the paper, the magnetic field will be anti-clockwise direction. The magnetic field strength is stronger near to the current field lines are closer and gets weaker further away. Field lines are further apart. So these are very, very important point as far as your paper number 1 and 4 is concerned. The magnetic field strength is stronger near to the current. Field lines are closer and gets weaker further away. Field lines are further apart. The larger the size of the current, the stronger the magnetic field strength. So this was lecture number 1. I hope so this will be much more easier for you to understand now. So read this lecture again, understand it, learn it, make your notes. Thank you so much.